All right, let's begin by checking your assignment from yesterday. And basically what I'm just going to have you do is you just pause the video as I go through the screens. I'm not going to talk through them. Just pause and check your own. Put a star by those that you have a question on or need more explanation on, and then we'll cover it from there when you return to class, okay? So take out yesterday's assignment, which was from page 150, 1 through 35. These were on absolute value equations. All right, so here is for numbers 1, 2, and 3. These were pretty straightforward. I'll highlight that on question number 2, whenever you're trying to take the absolute value of a variable and it says it's equal to a negative value, that's impossible. The absolute value measures a distance from 0. It's always positive or 0, and it can't be negative, which is why number 2 is no solutions. You'll notice there were a few of those further downstream in your assignment as well. Likewise for number 3, when it's equal to exactly 0, you don't break it into two cases, being positive and negative. If it's 0, it's just 0, and you only get one answer. All right, here's 4, 5, and 6. Again, pause the video so you can check your answer. Here's 4 and 5, and I'll now scroll down to give you the answer for 6. 7 is right here. Here's number 8, number 9, and number 10. And again, go ahead and look at the work in case you have questions. Here's 11 and 12. 13, looks like I forgot to circle this one. And 14. 15 is right here. 16. 17, and here 18 again, you isolate your absolute value and it equals a negative. That's impossible, which is why 18 is no solutions. Here's 19. 20 leaves you with some fractions, and here's 21. 22 also is an impossibility, so you write no solutions. Here's 23. And 24 ends up being no solutions. Now on number 25 and 26, these were ones where they gave you a situation about a number line. They set up 25 and it said basically you are 5 units away, so that's why they put the 5 on the right hand side of the equal sign. Okay, that's your distance here. This number is the starting point from which you're traveling on the number line. They said pretend you're at 3 on the number line right here, and you're either 5 units away in either direction. What would those values be? I think frankly visually drawing the number line, it's pretty straightforward. You go 5 to the right, 5 to the left, and your values are at 8 and -2. However, to translate it algebraically, here's what you do. In the absolute value symbol, because that means distance really, wherever I'm at -3, because that's where I'm starting, the distance from 3 is 5, and basically that's how you put it in there. Look at number 26. It was worded similarly. You're saying I'm at 7. I have a distance of 2. To write it algebraically, you write x minus 7 in absolute value equals 2. That means picture-wise, I am at 7 and I'm traveling a distance of 2 either direction, so you should get 5 or 9. 27, 28, and 29 were word problems. 27, they had it set up for you and they gave it to you in there. So as you solve it, you get 2 values, but because I believe this is something you are manufacturing and you have a certain variance or tolerance level, so you can get between 6.46 millimeters and 6.54 millimeters. 28 was similar. They described you as being at mile marker 207, and you have a radio or walkie-talkie that has a 2-mile range. So where would your basically your range of coverage on the walkie-talkie, where would you get between? It's between mile marker 205 and 209. This part may be more intuitive. To translate it back algebraically, that's the challenge right here. And 29, set it up as the absolute value of x minus 5 equals 1,000th. You'll get these two values, but this is like your upper and your lower limit, and you could be anywhere between them, between 4.999 millimeters and 5.001 millimeters. The last one's here for 30. There's your answer. 31, it's a little more complicated decimals. 32, and by the way, if you wrote negative 14/3 as negative 4 2/3 or as negative 4.6 repeating, that's fine. 33, you get negative 9.5, or if you wrote that as a decimal for one answer, and 3.75 or 3 3/4 as your other answer. 34, just take a look at the work here. I'm multiplying both sides by 3 so that I clear the decimal out of there after I break it into the two cases. And then you get to this stage, which is a piece of cake. And there are your two solutions. And the last one was pretty straightforward. Because it's equal to 0, you get one solution. So here's kind of a grading scale that I used for this assignment, since there were so many points on there. You can self-score that way. But now, what I want you to do is take a look at the notes sheet that I gave you for beginning this extension to Chapter 3 on solving inequalities that have an absolute value. Now, you just did the equation ones, so when we do the absolute value with an inequality, it's a little bit different. So take a look at number 1. The absolute value of x is greater than 4. Stop a moment and think of what are some 3 positive numbers that would be solutions that you could substitute in for x and make that true. Well, 5 works, 6 works, 7 works, and so on. You could be fancy schmancy and say 4.1. You could say 1 million. That works. But you get the idea, okay? Think of 3 negative numbers that would work, knowing that I'm plugging them in here. The absolute value will make those negative numbers positive. You would say, well, negative 5, negative 6, negative 4.1, negative 1 million. Then think about 3 numbers that wouldn't work, no matter what. I always think of 0 first. 0 is not bigger than 4. Positive 1, negative 1. Neither of those will work. Positive 2, negative 2, those won't work. Positive 3, negative 3. Okay? None of that works, but these things that are further out will work. And if I look at a number line, in fact, I put an open circle at 4, and you'd basically shade everything to the right. That would work. Okay? Likewise, anything in the negative section, put an open circle at negative 4 and start graphing this way. That would be a solution, but nothing in the middle. Now, this looks very familiar to what we just finished at the end of Chapter 3 with compound inequalities. This graph looks like this. X is greater than 4, or x is less than negative 4. Very interesting. Very interesting. All right, let's look at the next example. It's similar, absolute value of x, but this time I'm saying less than or equal to 3. Can you dream or brainstorm some positive solutions here? Well, 3 works. 3, I've got the equal sign in there, so 3 is equal to 3. Or I could have like 2, I could have 1. Oops, don't put 0 there. That's not a positive number. You could have 2.5, that kind of stuff. That looks like this, by the way. I'm thinking 3, 2, 1, 2.5, values in this era. 3 negative solutions. Well, if I plug negative 3 in, the absolute value would make it positive 3, and that would still work. Negative 2, negative 1, negative 2.5, all of this stuff works. So I'm just going to throw a few dots on here. 3 numbers that won't work. Well, let's see. Anything bigger than 3. So I could say 4 doesn't work, 5 doesn't work, 6, blah, 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 that way. Also, if I chose negative numbers like -4, -5, -6, and so on, those won't work when I put them in and take the absolute value. So what really is happening here is this time I have an upper and a lower bound, basically. I can choose any value that's sandwiched between -3 and +3, and it would be a solution for this particular inequality. This looks like this situation. X is in between or including -3 and 3. Now, sometimes we can also write it with two separate inequalities, so maybe I'll do it that way. I can say x is greater than or equal to -3, and at the same time, x is less than or equal to 3. Okay. Now, how does this all play out? Well, notice how this compared back to what happened when I had my original inequality up here. And in fact, I'm going to hop back to that first example. If this were an equal sign, okay, so let me just take a little detour and you don't have to write this down. But when I said the absolute value of x and I had an equal sign for 4, I said we could break it into two cases. Either you keep it as is, x is 4, or you'd say x is equal to -4. All right? Now, what's different about that example number 1 is I had the absolute value of x, and then I said that it happened to be greater than 4, I believe, right? Right. And what I got is this compound inequality with an or statement. Now, much like what we did before up here, where we said two cases, you're going to do the same thing here, but with a little twist. In one situation, you're going to keep it as is, greater than +4. When we do the second case, like up here in the inequality or the equations, I just said choose the negative sign there. Very similar, but I have to flip the inequality. Okay? I'm going to say x is greater than 4, just as is, and then I'm going to say x and -4, but flip the inequality to say less than. All right, let's take a look at the other one. All right, the second example that I gave you looked like this. The absolute value of x is less than or equal to 3. Okay, now let's remember how we handled that when it was an equation. The absolute value of x. Let's just say it was equal to 3. We'd split it into two cases, and you'd say x equals 3 or x equals -3. Now this time, with this inequality saying less than or equal to 3, and you saw what the graph was. The graph just had this chunk right here in the middle, and as you looked at it, you know, it was between -3 and +3, okay, and it was everything in between. So when we have the inequality symbol, yes, we're going to split it into two cases. The first one is going to stay exactly as is. Okay, so you'll say x without the absolute value symbol is less than or equal to 3. The other one, you're going to say x. You're going to use the -3, but this time you flip the inequality symbol. Okay, and you say greater than or equal to -3. Now, notice that the way this graph looked, you just get the overlapped region. So in this case, instead of saying or, this will actually be a compound inequality with the conjunction and, because you get these two which overlap each other. Okay, so as you look on your note sheet, we have these two lines here. So on the first line, here's what I want you to remember about solving absolute inequalities. Okay, of course you're going to get it to the point where you get the absolute value part of the inequality by itself. And the first thing you do is you are going to write the first case, and I'm just going to say as is. meaning you're just going to, like we did in this one right here, take your symbol is the same and the number value was the same, all right? So in other words, the inequality and the number stay the same. But for the second case, here's how you're going to write the second case. Okay, you are going to flip the inequality symbol, and you're going to use the opposite number, or in other words, in most of these cases for us, we're going to use the negative number, so the opposite sign of the number that's on the right-hand side. I also have these two symbols down under here. Okay, remember that in the second example, which had a less than or equal to symbol, this gave us an and situation. That's where we had an overlap. And then in the first example, where I had a greater than symbol, you actually have the or situation with two graphs going in the opposite direction. All right, so let's look at the three examples that I've got on your note sheet. Example number 1. Absolute value of x plus 10 is greater than or equal to 12. Your first goal is to get the absolute value portion of your equation by itself. So subtract 10 from each side of the inequality, and we're left with the absolute value of x greater than or equal to 2. Now you're going to split it into two cases. The first one you write as is. So x, you have greater than or equal to, and you have positive 2. The second case, you flip the inequality symbol, and you use the opposite or of 2 or negative 2. Because I started with a greater than symbol, I'm going to tell you this is an or situation. Don't worry about this part. Once you actually think about graphing it, it will become pretty clear, because you'll draw a number line out here. Here's 0. All right, so here's x is greater than or equal to 2. I get to put a solid dot at 2. I get to shade my number line to the right and fill in my arrowhead. So I'm going on to infinity this way. And then my other inequality is from negative 2. Again, it's a solid dot because I have the equals sign in there. And it's less than. So I'm shading into the left and I fill in the arrowhead. When I look at this, I say, oh, well, yeah, this is two things going in separate directions and there's no overlapped solutions, and that's why I use the word or. All right, look at the next example. The absolute value of x minus 3 is less than 1. All right, this one already has the entire absolute value part of the expression isolated, so we can jump right into making our two cases. The first case always goes as is. X minus 3 is less than 1. The second case, you'll say x minus 3, you flip the inequality and use the opposite of the constant of the number over here, negative 1. Solve each one and proceed. And right now, don't feel like you have to memorize or remember which way it goes. It'll all become clear once you get your solution out here. On the left, I get x is less than 4. On the right, I get x is greater than 2. When I look at graphing this, here's 0, 1, 2, 3, 4. This first inequality says x is less than 4. I put an open circle at 4, and I start shading to the left. However, at the same time, this inequality says x is greater than 2. I put an open circle at 2, and I start shading to the right. Haha, this is a compound inequality with an overlapped region. This is an and situation. And if you look up above, when we had a less than symbol, this is what we got. All right, last but not least, this third example. Oh, decimals. Heavens to Betsy, don't worry about that. First, get this absolute value region isolated. So we're going to subtract 1/2 from each side. That goes away. Now I just have the absolute value of x plus 2.5. is greater than or equal to, this will be 5.5. Okay. Now I'm to the point where I can split it into two cases. The first case is as is. X plus 2.5 is greater than or equal to 5.5. The other case, x plus 2.5, flip the inequality symbol and use the opposite of this one, negative 5.5. Go ahead and proceed to solve each of these inequalities. I get x is greater than or equal to 3. Nice. On this side, subtracting 2.5 from each side, that disappears. So I get x is less than or equal to negative 8. All right. If you're still unsure, just start drawing the graph and it'll become clear as to whether this is an and or an or situation. 1, 2. Here's 3. 1, 2, 3, 4. 5, 6, 7. Here's negative 8. All right, the first one, x is greater than or equal to 3. Solid dot, shade to the right, fill in the arrow. X is less than or equal to negative 8. Solid dot, shade to the left, fill in the arrow. I'm going to extend that out a little bit. This is an or situation. And yes, with the greater than symbol, that's what happens. So your assignment for tonight will be on page 215 in your textbook, 2 through 20 the evens. Get the absolute value part of your equation isolated and split it into the two cases and draw a graph. Good luck!